Hello, this is Dr. Rahman Ali, and I'm going to demonstrate MySQL implementation of the relational algebra operator here in MySQL Workbench. Uh, MySQL has the implementation for the basic relational algebra operator, unary operator selection and projection using select and where condition and select statement, and set operators implementation like union, intersection, Cartesian product, difference and division, and can have the implementation of MySQL Energine, which has equigiant, theta giant and natural giant as its subtypes, and the outer giant, which have left outer, right outer and full outer giant as their subtypes. We have already explained them in detail, and now we are going to explain how these could be implemented in MySQL Workbench. So I'm going to start my MySQL Workbench. I have already loaded it, and here I have created one database for this demonstration, Giant DB. Let me make this Giant DB is my active database. Use Giant DB is my active database. Yes, it is now active, and now I can apply the basic relational algebra operator. First, let's show tables, that what table this DB database has. It has department, department 1, department and students. These are the tables that we can see here: department, department 1, department and students. These are the four databases, and let's see what data department 1 has. Select asterisk from department. So select asterisk from department is the selection operator that select all the records from the department table. You can see here that all the records has been selected. So this is the selection operator, but selection operator is mostly used to select a subset of the records from a relation. So now let's select the subset. Select asterisk from department where. Now I am restricting this selection a subset of the records. For example, where budget is equal to budget is greater than, for example, 50,000. And now I am going to run it, execute it. So we can see that a subset of the database has been, a subset of the table has been retrieved. So this is the selection operator, that how selection operator works. Demonstration of the selection operator. And now let me demonstrate the project operator. So project can be demonstrated like, project is actually selecting a subset of the columns. This is the difference between these two. So I'm again using select. I'm only interested in the department name and their budget. So select department name comma department comma budget. Budget from department table. So it will select me a subset of the columns. There is some spelling mistake. Department name, yeah. Department name, NAME, Now let's execute this script again, and we see that two columns are selected. This is called the projection operator. So these are the basic operator of the relational algebra that are that could be implemented in MySQL. Selection and projection. The other operators are union, intersection, Cartesian product, difference, and division. So union cannot be directly implemented, and for union we have, yeah, this could be directly implemented. So let's demonstrate it. Now per union we have two tables, department 1, a department and department 1. If we see inside these tables, this department has from D1 to D8 details departments, and in department 1 we have D1, D2 common in both, and D10 and D11 which is new, which are not available in the department. So we are going to create the union, to apply the union. So for union I will do select I will select asterisk from department, spelling should be correct, department, department, select asterisk from department and take union with the select asterisk from the department 1, and now run. So it will select data from the department in department 1 and will take union out of these and will give me in a single table. And now we can see that D1 and D1 this and D2 and D1 and D2 are repeated, and D10 in 11 that was in department 1, so that is also added over here. So this is how union take place in MySQL. And how we could use the intersection. In intersection, the common attribute, the common record should be retrieved. So D1 and D2, that we can see that they are repeated in both department 1 and department 2. So for the intersection is cannot be directly implemented with keywords like intersection, but we can implement it with the help of energine. So let me apply the energine. Select, for example, department.static, which means that I want to see all the columns from the department table. Select department.static from department, from select asterisk from select department.asterisk from the department table having energine with the department 1 on the common attribute department dot department ID is equal to department 1 dot department ID. When I will execute this energine, it will return me common records between these two relation. So this is how union and intersection take place in MySQL. So the difference is A difference B. For example, A is my table department and B is my table student. So it will retrieve all the records from the department which belongs to department but not to student, where student.department ID is null. So this is the left join. Left join is used to demonstrate and retrieve the records for A difference B. Select all those records from the department having left join with the student on the common attribute department.department ID is equal to student.student ID, where for student the department ID is null. So when I execute it, it will retrieve me all those records that belongs to department table, but not to the student table. So this is the A difference B. For Cartesian product, for example, we have two tables A and B, and A, all the record, first record of A will be multiplied with all the record of B, second with all, and this way all the record will be displayed, and the column of both the table will appear in the resulted table. So how we could do this? For example, I am going to take Cartesian product of the department with the students. So I will select all the records from the department and all from the students, and I will use the join operator from department join student. And when I will execute it, yes, we can see that department 1 is multiplied with all the record of the student, then department 2, then department 3, and in this way all the set of the all possible combination are retrieved. So Cartesian product could be done with the help of join operator, or we can also use it with the help of cross join. The same query, but the same script, but with the keyword cross. So both keywords work the same. So this is how the basic scale operators could be implemented. Union, intersection, Cartesian product, difference, and division cannot be done directly or indirectly, but it needs simulation. So we will be discussing it later on when we will be discussing group by and having classes, and we